All right, so here's some examples of figures that are congruent, same shape, same size, same shape, and not congruent, different sizes or shapes. We good with that? Okay. Then example 1, there's 2 different questions for example 1. Identify any congruent figures in the plane. Explain how you know. So what we're going to do is we're going to identify them, and we're going to use geometry symbols to not have to write all the words out. Looking here, I see triangle EFG is congruent to triangle, anybody know the answer? What is it, Cameron? I just heard you say K. Oh, KML. Yeah, I'm gonna put it in the exact order that I wrote this in, so it'd be like KLM. Can you find another one that's congruent? Or maybe 2 more? Depends how many we have here. Lynn, what do you think? Okay, triangle, she said STU. So STU, and so if I say STU, I'm probably going to go JIH. So I can put them in the same order, like the corresponding angles are going to be, or the corresponding vertices are going to be in that same order. Or HIJ, maybe kind of hard to tell which one corresponds for that one. Okay, and then is there any more? All right, I'll give you a hint. A, B, C, D. Quadrilateral, or maybe a square in this case. A, B, C, D is congruent. Oh, sorry, you can't see it. Is congruent to. What do you think? NPQR. Is that what you said? Okay, now we have to say why. So the definition of congruent figures says that it can be mapped onto the other one by a rigid motion. So it could be rotation, it could be reflection, it could be translation. Let's figure out why. Can we start with triangle EFG going to triangle KLM? A reflection in what? Reflect in x-axis. Good. How about the other triangles? We said that S and J correspond to each other. I probably could have said S and H correspond, but we said S and J. So what kind of transformation would that be, Lynn? Use the proper like terminology. Reflect in y equals x. I know it's weird to say that. I say it in all 3 classes I teach, and every single time, but that's how they say it. Triangle, no, not triangle, sorry. The square ABCD, or rectangles ABCD, or quadrilateral ABCD, and NPQR. How do we get from this one to this one? Stephen, I know you know. Translation. What translation? If we start here at D and we end here at R, what is the translation? Down 6, and then which direction over? Left 2 units. Yep. Okay, let's look at the next one, and I want you to kind of take about a minute to 2 minutes and start writing down what you think is congruent and start thinking what transformation took you there. Good use of symbols. Okay, you might have it written slightly order you put your letters in, your vertices. I'm going to start with the rectangle, so I'm going to draw a rectangle. Or you can write the whole word out, rectangle. But I like when you guys use symbols. So rectangle, G-H-I-J. I want to put it in order. G-H-I-J is congruent to rectangle. So if I started at G, probably going to start at N, N, P, Q, R. So you guys, you want the corresponding points to be in the exact same order for both of these. Also, when you name rectangles, which we really haven't done so much yet, is you have to go around the rectangle. You can't be like N, Q, P, R. It has to be around the rectangle. Okay, why are these congruent? John? You can translate down 6. Okay. Is that the only thing that could have been done here? Could you have done a reflection? Maggie, could you have done a reflection? What would you reflect in? Oh, would it be a half? 1, 2, 3, 4, 5, 6. So yeah, it'd have to be here. Yeah, you're right. Also, if we did reflections, then G would map to P. So if I did it by reflection, then I'd have to reorder these letters over here. But since I ordered them in this way, its translation is perfectly fine. Either answer would be fine. You just have to like order them the correct way. Okay, how about triangle? LKM. So triangle LKM, in order of L, then K, then M, what order should I go over here? Oh, TSU. I didn't know who was second. Yes, Rakaya. Okay, so what is happening between these figures? Jesse, do you know?
Yeah, you would do reflection over the
In the
y-axis.
In the yeah, I know. Reflect in the y-axis. Excellent. And then that leaves us with triangle DEF. Put in order. DEF. I could have written it the way that I said at first. So before I say what it's congruent to, because I really need to think about the order when I write down this one, I need to think about the order. How is this going to be congruent? By what transformation? Ryan? A rotation, right. So if I'm thinking about rotation, then D should map to which letter over here? Abney? A, yeah. We're thinking about rotation, those two will map to each other. So I'll write triangle ABC. It's a rotation. Now we need an angle. Rotation about, is it about the origin? Yeah, it's about the origin. We need an angle. So maybe I'll look at C and connect it to the origin, and then I'll look at F and I'll connect it to the origin. What angle do you just think that might be? Yeah, it's going to go counterclockwise, which is weird, but this is for real. Like in math, we always go counterclockwise. So it looks like it's 90 degrees. I can find out for I know my 90-degree rotation rule. Does anybody have their 90-degree rotation rule handy? What is it? Okay, so for 90 degrees, it's negative y x. So if we start at 2, 1, and then we at negative 1, 2, does that fulfill that? Oh, I'm sorry, I wasn't on that. Does that look like the formula there? Does that look like the rule? Okay. Speaking of these rules, talk to the other geometry teachers, and this is not something that's given to you for the air testing. So this would be something that you would need to have memorized. How do you guys go about memorizing stuff? You do it over and over again? How else? Other ideas, Maggie? Teach somebody else, yeah? Or like help, I mean not necessarily teach, but if you're helping explain it to a friend that needs help, that'll help you remember it better. What else? You got another idea? 17? Okay, 17 times. Do you know like 34 times on average is what it, or maybe it's 35, 34 or 35, I don't know. On average is what it takes people to commit something to long-term memory. There's a stat somewhere. But if you commit it wrong, like if you practice something wrong like 35 times, to correct that in your brain, it takes you like 900 times of doing it the right way to correct that in your brain. So it's best to do it right the first time. Okay, so anyway, I was going to say make flashcards. Like quiz yourself, check that you're right. That's another good way of doing it. Did anybody else have anything else? Make a Quizlet. Maybe there is something online that already exists for you that you could use. But those do need to be memorized. All right, next section. Congruence transformations. Another name for a rigid motion or combination of rigid motions is a congruence transformation, because the pre-image and image are congruent. The terms rigid motion and congruence transformation are interchangeable. That means these are exactly the same thing. All right, I have something called patty paper. It's basically tracing paper. You do not waste this because I'm not going to give you a new one every single time you need to use it, but I'll show you what it does. Oh, look how traceable that makes it. See, when you push it down, you can actually trace a figure. We are going to describe a congruence transformation that maps these, and I just want to show you how you guys can use this to actually move it around and figure it out. All right. If you plan to use this on your homework and on other things, just use the top corner when you trace the first figure. Just use the top corner. Don't put it right in the center. That way you can on this next one use right underneath it, and you just kind of use the whole paper as the semester goes. If you need it, you might not even need this. I just wanted to show you how this maybe helps somebody differently, because not everybody sees everything the same way. I am somebody who really likes to see things happen. So for me, this is helpful. I'm a pretty visual and kinesthetic learner. We're on the next page. Okay, go ahead and trace. Do this for fun. See if it helps you. Maybe it does. Trace. Parallelogram, ABCD. See how they wrote parallelogram, ABCD in the directions? Do you see how they wrote that? Okay, then we have to describe a transformation. So, could it be a reflection? To do a reflection, you have to turn the paper over. Is that going to work? No, it doesn't look like it. Okay, could we do a translation? Could we take this and slide it and have it match up? So I've X-nayed 2 of them. What should I try? Rotation. So if I rotate this around, will it match? Probably. Let's see. They said that A should match to E. Do I have A and E matching? Do you have A and E matching as you're trying this with me? Yeah. And then B matches to F. Is that true? I have to look underneath. Nope. Maybe they put it in the wrong order, though. Or maybe I just didn't rotate it correctly. Oh. Maybe it's not a rotation. Maybe it's a reflection and a translation. Oh, I'm not looking at the answers. I'm figuring this out with you right now. Let's see what the answer says. Ha ha ha, that's what the answer says. It says it is a reflection. You guys, do you see what threw me off? Why I said it wasn't a rotation? Did you see what I was figuring out? When I was looking to see that A matched up with E, but then B did not match up with F. So I knew it couldn't have been a rotation. So then I was looking A, B, and then if E and F match up, they have to flip over. So if they flip over and then translate down, I think we're good. So let's write the congruence translation. What's my first transformation? Right? The two, the A and the A prime would be the same distance from the y-axis. So we first reflect in the y-axis, and then after that, 1, 2, 3, 4, translate down 4 units. See the patty paper, maybe you saw that on your own. Does anybody see that on their own? Okay, so let's try the second one. I want you to play around with the patty paper for, I don't know why it's called patty paper, by the way. Play around with the patty paper for a moment and see if you can figure out a transformation or a composition of transformations. If you are actually watching this video and listening to my words, I forgot to copy and paste this part of it, and you need this part to do it correctly. So this says to start with JKL, and we end up at MNP. So J has to correspond to M. I walked around the room, and you guys, I saw 2 different answers, and both of them were great. I saw a lot of people that said, let's reflect in the x-axis first. So we reflect in the x-axis, and actually a lot of you just drew it here, which is great. A lot of people just drew it here. So this would be J prime, this would be K prime, and this would be L prime. So reflect in the x-axis. This is not the only correct answer, so if you didn't do it this way, just hold off because I'll go over another correct answer. Reflect in the x-axis. And then if we reflect that, and I know that J has to correspond to M, L corresponds to P, this is now just a translate. So we translate to the right, 1, 2, 3, 4, 5. Okay, so translate right 5 units. That answer works very well. The other answer that I saw, I'll do it in a different color, is some people said to first translate to the right 5. So that would be J prime, K prime, L prime, and then reflect in the x-axis. It's kind of saying the exact same thing, but just in the other order, and that would also work. Does everybody have a different one? Okay. All right, this is a theorem. Reflections, parallel lines theorem. This says if K and M are parallel, so we've got 2 parallel lines, how can I look at these and know that they're parallel? They have those little arrows that mark them and say parallel, besides the fact that I just read they're parallel. Then a reflection in line K followed by a reflection in line M is the same as a translation. So what we have is we have figure AB. In the book these are colored, but I can't give you colored copies. If you look at my blank notes, but they're not uploaded yet. If you look at the blank notes on canvas, they are colored. That reflects to, here we have A prime, B prime. And then reflection again, we have B double prime, A double prime, or A double prime, B double prime. So what this is saying is if I do a reflection and then another reflection over parallel lines, then that's the exact same thing. It's just going A, B all the way to A double prime, B double prime with one translation. That's what that's saying there. If A double prime is the image of A, then A double prime is perpendicular to K and M. So you see how they've marked them perpendicular. So if I were to draw the translation line from A all the way to A double prime, that would be perpendicular to the parallel lines. And the length of A double prime, see how this one's length? How do I know its length besides it says equals a number? How do I know its length? By looking at the A double prime. How do I know its length? How's that different than talking about the segment itself? We need to review this. Anytime we're talking about the segment, there's a little line above it. If we're talking about the distance, the length, there's no line above it. So it's the exact same the exact same location, the exact same thing we're talking about, except for one is the figure and one is how long it is. So A double prime equals 2D, where D is the distance between K and M. So between K and M, see how we have D? D is the distance between K and M. Then the distance from A all the way to A prime is 2 times D, so twice D. So that is a theorem. Here's our next example. In the diagram, a reflection in line K maps GH to G prime H prime. A reflection in the line M maps G prime H prime to G double prime H double prime. Also, HB is 9 and D H double prime is 4. Let's mark some things. HB is 9. H to B is 9. D, where's D? D to double H prime is 4. Name any segments congruent to segment GH, HB, and GA. GH, HB, and GA. Where's GA? Oh, right here. So do we have anything congruent with HG? Let's see. Let's see. Who wants to talk? Aaron! Anything congruent with HG? Oh, GH. GH. They wrote GH, sorry. GH, congruent to what? Yeah. Any others? Yeah. Right, the actual figures that are being reflected are going to be congruent. How about segment HB? Segment HB that I marked as 9. Lynn?
HB.
Huh?
It would be BA. Or no, HB. I'm sorry. It would be GA. Or no.
No?
Sorry. It would be hold on.
What's happening over this line, in this line?
Hold on. HB, right?
HB is what we're looking at, yeah, this one right here.
So, would it be
See? You get it.
So HB would be H double prime, or H prime and B.
Okay, HB and H double prime B, yes, those are going to be the same length because this one's reflected to here. So those are going to be the same length. So H prime B. Something's happened to my blue pen. I think that's it for that one. Double check, but I think that's it. Yep. How about GA? So here's GA. Denise, can you help me with GA? It's not going to be G prime and C. What's happening over this line, in this line? What's happening in this red line? Yeah, but if I'm not even looking over here, what is this line used for? Jay, do you know what this line is used for? You're still answering the question. I'm just asking other opinions. Do you know what this line is used for, Jay?
Make the right.
Well, the right angle is formed because of something else. Matthew, do you know what's happening in this? In the line. It's a reflection. We're starting at HG and we're reflecting over this line, in this line, and getting to H prime, G prime. So Denise, what is congruent to GA? G prime A, because it's just a reflection of this figure. So these will be congruent. Okay, the second question. Does the length of AC equal the length of BD? Explain. So the length of AC is, where? AC equal the length of BD. Explain. David, do you think that they equal or not equal? So you think that from AC and from BD, they're the same length. Why? Okay. So you're saying because these are parallel and we've got perpendiculars. Okay, there's a different way I'm going to write down to explain it. Rakaya, do you know? The reason I'm looking for? Because line K and line M are parallel. And what do we know about parallel lines? Not congruent. What is the definition of a parallel line? Say it again. Oh, they never intersect. And so what do you know about the distance between those lines if they never intersect? It's going to be the same distance. And we know that it is distance because of what David said, that these are perpendicular. That's why we know it is distance, but it's because that's like what parallel lines do. They have the same distance between them the whole time. Yes, because lines are parallel. And perpendicular. There you go. What is the length of G all the way to G double prime. Of G all the way to G double prime. We need the length of G all the way to G double prime. We need this length. I wonder if it has anything to do with the 9 and 4 that they told us earlier. So they want a length, they need numbers. Now the reflections and parallel lines theorem tells you how to find it. It says the length of A to A double prime is twice the length of the inside. Did they tell us inside BH? Did they tell us that amount? No. But what I do know is that HG is also a translation to H double prime G double prime. So the length from H to H double prime is going to be the exact same as the length from G to G double prime because it's a translation. So if I find the length of H double prime, then I know the length of G double prime. So from H to H double prime, how far is it? Lynn? 26. I don't see 26. I see a 9 and a 4. How'd you get that? The question I called you for, since that is 9, what's this little guy going to be? That one's going to be 4, because these two will be congruent since it's a reflection here. So we add all of that up and we get 26. All right, there is a U-try. Use the figure. The distance between line K and line M is 1.6 centimeters. Line K and line M, the distance between those is 1.6 centimeters. I want you guys to try. Let's see what kind of answers we can come up with. Okay. Let's see. Emily, can you help me out? What is the single transformation that maps the blue figure to the green figure? It is. Can you tell me, like, direction it translates? And do you know how far it translates? What? Did you answer question 6? Yeah, did you answer that question? Okay. Translation, so many centimeters to the right. Jay, do you know how many centimeters it's going to translate? 4.8. Hmm? How'd you get 4.8? Okay. So the formula, not the formula, the theorem above says that the full distance is going to be this distance. So you did 3 times, but it should be twice. Excuse me. 3.2. Okay, what is the relationship between P prime and the line K? So we're talking about, I drew it in yellow, what is the relationship of this entire segment and line K? What is their relationship? I did not see many people have this answer. Austin, do you have that answer? Okay, well, look at it. What can you tell me about this thick yellow line and line K? I even marked it. They're perpendicular. See, you can do that. And the reason why they're perpendicular is the reflections in parallel lines theorem. Theorem 4.2, reflections in parallel lines theorem. And then finally, what is the distance between P and P double prime, Raylan? Well, we already discussed it while we were going over another question up here. Yeah, 3.2. You take the distance between the two parallel lines and you double it. Centimeters. All right, last section. This one is reflections in intersecting lines theorem. So these aren't parallel lines, these are intersecting lines. So in this picture, we've got lines K and M are intersecting at point P. So here's line M, here's line K, and they're crossing at point P. AB that is reflecting, okay, becomes line or segment A prime B prime, and then A prime B prime reflects in line M, and it becomes double prime B double prime. When we do this, this is the same as a rotation about point P. The angle of rotation is twice x, where x is the measure of the acute or right angle formed by lines K and M. So in here you can see lines K and M intersecting, and they have written x degrees right here. So the rotation, if I was going to look at this as a rotation from like point A all the way around to point A double prime, be 2x degrees. So you take it times 2. So it's kind of the same rotation rather than translation. Using the reflections in intersecting lines theorem, the image, in the diagram, the figure is reflected in line K. Then the image is then reflected in line M. Describe a single transformation that maps F to F double prime. So it's going to be a rotation about point P of how many degrees? From point F all the way around to point F double prime. How many degrees is that going to be? Use your theorem. What have I not called on? Have I called on everything? I called on you, right, Stephen? Called on Aaron. I think I called on everybody. Alex, do you know what it is? Okay, what's the theorem say? The angle of rotation is? Okay, so what's x in this case? So what's my answer going to be? Right. 140 degrees. You guys can figure this out. In the diagram, the pre-image is reflected in line K and then in line M. Describe a single transformation that maps the blue figure onto the green figure. I better tell you which is which. Blue figure is this one. Blue. And blue is about dead. And then the green figure is this one. Single transformation. Avneet. Rotation about point. Which point are they rotating about? Around, about. No, that's the degrees. I want to know which point, like the center of the P, point P of 160 degrees. Good. And then a rotation of 76 degrees maps C to C prime. To map C to C prime using two reflections, what is the measure of the angle formed by the intersecting lines of the reflection? So this is saying we have two lines and we have some figure here, and then it rotates 76 degrees to start, go from C to C prime. Now they're saying if we instead did reflections to get there, so this would be like a reflection, and then this would be a reflection. I don't do a very good job of drawing it. If we did reflections to get there, what would be this angle between the two lines? Stephen? Yes. So they are telling us the angle that takes the figure from start to finish, or telling us the rotation angle. But if we were going to do it this way, we've got reflection then reflection. What would this angle between the lines be? So I'm looking like 80 degrees would be my answer, but it's not because it's different starting. So that one is going to be 76. What's this one going to be? So if you look at the last one, 80 was in between the two lines, and we did 2x to get 160. This one, 76, is the rotation, but between the two lines is what we're looking for. So we're going backwards.
38.
Yes, 38. I didn't do the math. 38 degrees. Yeah, so we're going backwards. You're going to divide by 2. All right, so the assignment is going to be page 204, but I haven't given you books. If you have to get a book checked out, and just use your Chromebook. Remember how we used our Chromebook to open the book and find vocabulary definitions? You can open up your Chromebook. You can use your online what's it called? Student edition of some sort. No, I forget what it's called. Dynamic edition or something. I don't know. But you can use your online book, and then the numbers are 3 to 16, 24 to 28. It says get graph paper from Mrs. Criswell, so I'm going to hand you graph paper. You can work on this, or you can work on your tessellation project for the rest. Okay? Probably a lot of you might need help with the tessellation project or have questions, so that's why we're doing it in class, where it is due Friday, and so is this. Okay?